We're going to explain how to sort a 2D array in Java. There isn't a built-in function to directly sort a 2D array like you might find for a 1D array using arrays sort ot. Instead, we need to think strategically about how we want to sort the data. Do we want to sort each row individually? Each column? Or maybe sort the entire 2D array based on a specific criterion, considering all the elements together? Let's explore some approaches. 1. Sorting rows individually. If you need to sort each row of your 2D array independently, you can iterate through each row and apply arrays.sort to it. This assumes your 2D array is an array of arrays, e.g. int myArray. The code would look something like this. For each row, outer loop, use arrays.sort myArray, where I is the row index. This sorts each myArray, which is a 1D array, in ascending order. 2. Sorting columns individually. Sorting columns is slightly more complex. We can't directly use arrays sorting on columns. Instead, we need to iterate through each column and create a temporary 1D array containing the column's elements. Then, we can sort this temporary array and copy the sorted elements back into the original 2D array's corresponding column positions. We'll need nested loops, one for iterating through columns and another for iterating through rows within a column to build the temporary array. After sorting the temporary array, another nested loop would be needed to write back into the original 2D array. 3. Sorting the entire 2D array based on a custom criterion. This is the most general case. If we need to sort the entire 2D array based on some specific rule, e.g., sorting based on the sum of elements in each row or based on the largest element in each row, we can't rely on built-in functions directly. We'll likely need to create a custom comparator for arrays sort, or utilize a sorting algorithm, like merge sort or quick sort, and implement the comparison logic ourselves within the algorithm. The comparator would define how we compare two rows or any other unit of the 2D array. Comparator would take two rows, or units defined by your criteria, as input and return a negative integer if the first is less than the second, 0 if they are equal, and a positive integer otherwise. You'd then use this comparator with arrays.sort on an array of rows, each row being treated as a single element for sorting. 4. Using a library. For more complex sorting needs or for improved performance with large data sets, consider using a Java library designed for efficient array manipulation and sorting. These libraries often provide optimized sorting algorithms and utilities that can simplify the process significantly. The use of a library would reduce the complexity compared to the custom comparison and sorting implementations. In essence, sorting a 2D array in Java involves either iterating through rows or columns and applying arrays sort to individual 1D arrays, or creating a more complex custom sorting solution depending on the desired sort order and the criterion for comparison. Remember to choose the approach that best matches your specific sorting requirements and data size. Libraries can greatly simplify the implementation and improve efficiency.